Okay, number 11. We want to find K so that the line is parallel to the line that goes through these points. So really that's what I need to start with, is to figure out what the slope of this one is. So I'm going to do 4 minus negative 8 over 2 minus 5. So that would give me 12 over negative 3. So I want my slope to be a negative 4. Now I'm going to take this other one and put it in slope-intercept form. So I have to subtract kx. So I get 9y equals negative kx plus 4, and then divide it by 9. So the slope is negative k over 9. So negative 4 has to equal negative k over 9. Because if they're parallel, the slopes have to be exactly the same. So what I'm going to do is multiply both sides excuse me, by negative 9. It gets rid of the 9 and it gets rid of the negative sign, and I get 36 is equal to k. Alright, now we're on to the circles. So we know that the basic form for the circle is x minus h squared plus y minus k squared is equal to r squared. So it's always the opposite sign. So determine the center. There is no adjustment here, so the x-coordinate of the center is just 0. Since it's y minus 5, it's the opposite side, the y-coordinate of the center is 5, and this is the radius squared. So when you take the square root of that, we get 7. For 13, it's not put together for us, so we have to complete the square in order to get the center and radius. So I'm just going to rewrite them with the variables grouped together. And I'm pulling that 21 over to the other side, so it becomes a negative 21. So what I need to do is take the coefficient of this, the first degree term, divide it by 2, and then square it. So negative 8 divided by 2 is negative 4, and then square that. So negative 4 squared is 16. So I just added 16 on that side to keep it balanced. I need to add 16 on the other side. Then for this negative 6, divide that by 2, and we get negative 3. And you square that. Well, that's just equal to 9, so I added 9 to one side. I have to add 9 to the other side. What I've created is these perfect square trinomials, because this is x squared minus 8x plus 16, which is x minus 4 squared. This term, y squared minus 6y plus 9, is the same as y minus 3 squared. And then on the other side, I just need to add those terms. And that just combines to a 4. Now that everything's in the correct form, I know what the center and radius are. It's the opposite of that. So the center, the x-coordinate is 4, the y-coordinate is 3, and then this is radius squared. So the radius is equal to 2. They're telling us the center and radius, and we have to write the equation. So again, it's always the opposite sign, so it's going to be x minus 1 squared plus y plus 5 squared equals square root of 13 squared, which is just 13. We have to sketch the circle. So we really can do process of elimination, a lot of this. The center is going to be 1, 4, and the radius is going to be 2. So we're at 1, 4, and then we go 2 units in each direction. So if I'm looking at these, this is the only one that it could be. Number 16, find the coordinates of the vertices and foci of an ellipse. So we know it's an ellipse because it's plus. If it was minus, excuse me, that's when it's a hyperbola. So the vertices and foci. This is the major axis because it's a bigger number down there. So that's a squared. So I have to take the square root of 625. And I get 25. So because there's no adjustment here, I know that I'm going to have vertices at negative 25 and positive 25 on the x-axis. The b term is the square root of 225. Which is 15. Now they want us to find the foci as well. So far what I know is it crosses at negative 25, positive 25, and then 15 and negative 15. Those are not the vertices they're looking for, but this is what my ellipse, oops, looks like, kind of, sort of. So I need to find what these foci are. So to find the c term, we need to use the fact that a squared equals b squared plus c squared. So a squared was 625, b squared is 225, and we have to use that to find c squared. So I'm just going to subtract 225, and I get 400 as c squared, and then take the square root. So I get 20 as c. So my vertices were at negative 25, 0, and 25, 0. And my foci are at negative 20, 0, and 20, 0. For 17, we want to do another sketch. Again, they're added together. So this is an ellipse. Y is the major axis. Crosses at 6 and negative 6. The x crosses at 3 and negative 3. I cannot see, so sorry about this. And that's what our ellipse would look like. So again, the only possible choice that makes sense for that is C. For 18, find the equation of ellipse satisfying the given condition. The minor axis is 22 units long, and the vertex is at negative 12, 0. So I have negative 12, 0. The minor axis is 22, so that means it crosses at 11 and negative 11, because that would be 22 units long. So we know that it has to look like this somehow. So if there's negative 12, 0 for a foci, then the other one's at 12, 0. So what do we know so far? We know the x is the major axis, because the foci always fall on the major axis. We know what b is. B is equal to 11. And we know c is equal to 12. So again, I need to use the fact that For an ellipse, it's a squared equals b squared plus c squared. So I don't know what a squared is yet. B squared, 11 squared is 121. And 12 squared is 144. Oops, I plugged something in wrong, sorry. So I got a squared is equal to 265. Which does not match. Minor axis is 22. Vertex. Oh my goodness, it says a vertex is at negative 12, 0. And I kept saying that the foci is at negative 12, 0. So I already have everything I need. I'm sorry, I did all this extra work for no reason. It actually crosses at negative 12 and 12. So my A term is 12, so I get 144. So it should be x squared over 144 plus y squared over 121. Oops, sorry.